Hello guys, welcome to Free Shiksha. Today we are going to learn about Le Chatelier's principle. It is also called Le Chatelier's principle, whatever is the pronunciation. I'm not very sure of that, but it is a principle which is related to reactions in equilibrium. So basically, if we are given a reaction A moles of A plus B moles of B giving C moles of C plus D moles of D, this reaction is in equilibrium. How do we know that? Because there is an equilibrium sign between the reactants and the products. Okay, so the question is, what will happen if we increase the concentration of A? Okay, so if we are increasing the concentration of A in this equilibrium reaction, what is going to happen? Okay, second question is, what will happen if we increase the concentration of B? A reaction is in equilibrium, and if we increase the concentration of any of the reactants, what is going to happen? So basically, if we increase the concentration of A, that means more A's are available to get reacted with B's, and therefore what will happen is reaction will not be in equilibrium for some time because more reactions will start happening. So more of A is there, so it will react with the B present in the environment because availability of A has increased. So that will react with B, consuming some of the B's. So the concentration of B will go down and the concentration of products will increase, and a stage will be reached such that again equilibrium will be attained. So if you increase the concentration of either A or either B, or if you increase the concentration of both A and B, then both will react, and at a certain stage a new equilibrium will be attained. However, it should be noted that equilibrium constant remains constant. Even if a new equilibrium is attained, equilibrium constant will always remain constant. Now suppose there's one more scenario. If we increase the concentration of C in this equilibrium stage, what will happen? That means more of C's are available for D's to react, and hence the backward reaction will start happening. Backward reaction is C reacting with D giving B and A, and therefore D's will be consumed in the reaction, and a new equilibrium after a certain stage will be attained, wherein the concentrations of A, B, C and D will change, but the equilibrium constant will still remain constant, will remain the same as before. Okay, so if any changes are done in the conditions of the equilibrium reaction happens in a direction which tries to counter the change experience. So that is what Le Chatelier's principle is. So whatever changes we do in the reaction in the equilibrium reaction, so the certain changes happen in the reaction so that they are able to counter the change that has happened. So if we increase the concentration of A, so the reaction will try to decrease its concentration to attain a new equilibrium, and hence the reaction will happen in a forward direction. Similarly, if we increase the concentration of D, that means the reaction will happen so that it can reduce that concentration. So whatever change that happens in the reaction, in the equilibrium reaction, the forward or backward reactions occur in such a way so that they can counter the changes that have happened in the equilibrium. So now there's a reaction, say YA plus ZB, Y moles of A plus Z moles of B giving P moles of C. So if Y plus Z is greater than P, that means Y plus Z moles are greater than P moles. So what will happen if we decrease the volume? Okay, this reaction is happening in a container full of which is full and has these contents. It is these reactants and products. So if Y and Z are greater than P, and if we decrease the volume, then the reaction is going to favor in forward direction because P moles are less than Y and Z, and we are decreasing the volume. So reaction will, as we studied, it will try to counter the change that has happened. The change that has happened is reduction in volume, and because the volume has reduced, we need to so reaction needs to happen in a way that uh, so that the lower volume it requires, and hence forward reaction will start happening. Similarly, if we take an example of Haber's process, nitrogen is reacting with 3 atoms of hydrogen, giving 2NH3, ammonia gas. So here we can see that 1 mole of nitrogen reacts with 3 moles of hydrogen, giving 2 moles of NH3. So on the right side we can see the moles are less than on the left side. So on the left side more volume is occupied by the molecules, on the right side less volume is occupied by the molecules. Now if the question is what will happen if the volume is decreased, the same thing here. If the volume is decreased, the reaction starts happening in a forward direction, because so that the products are formed which occupy less space. Now there is one more question related to this: what will happen if pressure is increased? Again, if the pressure is increased, we know that pressure is inversely proportional to volume. PV is equal to nRT is an equation, and we had seen that P is inversely proportional to V, and hence if we increase the pressure, that means the volume is decreasing. So when the volume is decreasing, our question boils down into the previous question itself, that the volume is decreasing. So if we are increasing the pressure, volume is decreasing. So again the reaction will start happening in a forward direction. So to explain it, if this is the container and here is 1 mole of nitrogen and here are the 3 mole of hydrogen, and we are trying to give pressure to this, we are increasing the pressure in this container. So the molecules are coming closer, so they will be in a better position to react, and hence and the formation, and these are the products with NH3, 2 moles of NH3. So it is better to attain this stage from this stage, isn't it? When there is applied pressure, I should have made these are 2 molecules of NH3, so I should have made 6 molecules of hydrogen as in, and 2 moles of nitrogen, but this is explanatory. It is better to attain this stage on an increased pressure. This is how we have to tackle the Lee-Chatelier's questions related to Lee-Chatelier's. Now again there's one more question. Now A moles of A plus B moles of B plus heat gives C moles of C plus D moles of D. So for this particular reaction you require heat to be there for a forward reaction. Okay, so now what will happen if more heat is given to the system? So it's a very simple. If we are increasing the heat which is there, the system will try to counter the effect of it, and because we know heat increases the rate of reaction of this reaction, so when in equilibrium if we add the heat, the reaction will again start happening in the forward direction. Now if the reaction, again if I ask you a question, supposing if we do not give it a heat, if we do not give it heat, suppose we take away the heat from the system, what will happen? Try thinking about the answer. So guys, what will happen is if we reduce the heat from the system will try to generate more heat, and in turn the reaction will happen in a reverse direction. So backward reaction will be followed if the heat is removed from the system. Now there is a sample problem for you. At equilibrium concentration of A is 2 moles and B is 4 moles and C is 8 moles. If after adding some more A has been added in the reaction, new equilibrium is achieved after some time with the concentration of A being 4m. So what happened was we have added few more quantity of A in the reaction, and after some time a new equilibrium was achieved where the concentration of A was 4 moles, C being 10 moles. So what will be the new concentration of B? So can you solve this problem? I will give you a small hint that we have to use equilibrium constant to solve this problem, and we'll solve this problem in the next video. Thanks a lot guys for watching. All the best.